Jai Sri Ram, dosto. So today we are going to solve Koko eating bananas problem. That is a medium level problem in which we would be using binary search operation. But before telling you the approach, uh, let me tell you about this particular problem first, and then we would be moving to the solution part of it. Okay, fine. What problem statement states that Koko loves to eat bananas. There are n piles of bananas in which it will have p of I bananas stored in it. You can consider piles that are as a array or array list in which we would be having at each index it will contain n numbers of bananas in it, x number of bananas in it, and the guards have gone and will come back in h hours. Okay, there's another thing that there's a problem of guard in which we would be having a guard who is actually securing what? It is not securing the API, he is actually securing the guard, uh, in which we would be having bananas, and Coco is nothing but it's just, I think it's a monkey or someone else. Okay, let's come back to the problem. Coco can decide her bananas per hour eating speed of k. Okay, in each hour she chooses some pile of bananas and eats k bananas from that pile. If the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. Okay, fine. So Coco likes to eat slowly, but still wants to finish it eating all the bananas before the guard return. So what we need to return is return the minimum integer k such that she can eat all the bananas within small h hours. So let me tell you the problem and approach. So what is the problem? Is it there's a pile that are four pile 1, 2, 3, 4, and for each pile it will contain some bananas in it 3, 6, 7, 11, and there is hour in which the guard will return. So for 8 hours, Coco will have a time to finish all the bananas, and it will the guard will shock that they have no bananas as of now. So what we need to do is we just need to go to meet Coco and help her to eat complete bananas in a minimum integer k. It's a most important thing to understand that minimum integer k is nothing but it's a rate. It's a rate. It's a minimum rate in which she can complete the complete bananas, and uh, so that she can eat slowly as well. Because yes, she can also have uh, finished this particular thing. Maybe she can have a speed of 10 bananas per hour. So how she would be having it if she has a speed of 10 hours 10 bananas per hour? Then in the first round she will eat this. In the second round again she will finish this in a second hour. Another hour she can easily finish these things. But if she has the capability of 10 bananas, then again she would be having 2 hours to finish this. So the complete would be 2 plus 3, 2 plus 1 plus 1 plus 1, that is 2, 3, 4, 5 hours. So 5 hours are sufficient because he can finish it off in 8 hours. But let me tell you another thing. Uh, Okay, 10 hours, 10, sorry, 10 bananas in an hour would be a little faster if we can take again 8 bananas per hour. So how C will finish? Let's suppose C is having speed of 8 bananas per hour, and in this particular pile C would be finishing it in 1 hour. Again C can finish it in 1 hour. Again C would be finishing it in 1 hour. Again C would be taking 2 hour, because if we divide 11 by 8, so in first round C will finish 8 bananas, and the second round she will uh, have to finish the remaining 3 bananas. So again this will again give the 2 hours. So again the output would be the same, 2 hours plus 1 plus 1 plus 1. That is also same at the 5 hour. Again she is completing all the bananas in a 5 hours, but the speed is a bit low. I hope you are getting my point, because there's another constraint that we are having, that is Coco likes to eat slowly, not the faster one. Okay, let's suppose, let's say, let's reduce the rate again. If she goes with the 4 bananas per hour, so how will she eat? Let us discuss it again. Okay, 4 bananas per hour, so it will give 1, and this will again give us 2. This is also give us 2, and this will give us, if we divide 11 by 4, and if we every time we need to take the seal value. What is the seal value? Seal value is nothing but you can take an integer value first and then add 1 in it, so that we can get the upper limit. If it is 3.2, if it is 3.7, we need not to take the 3 value, we will need to take the seal value of it, upper value of it, that is 4. Again, if we divide the 11 by 4, then it would be 11 divided by 4, that is 3, 2 point something. So but what we need to take, we just need to take the 3, the seal value of 2 point something. So it will give 3, it will give 2, it will give 2, and then it will give the 1, then 3, 4, 5, 6, 7, 8. Absolutely correct. So C again can finish these things in 8, exactly in 8 hours. That is already mentioned over here, and the rate is also a bit low, that is 4 bananas per hour. Let us take another variable, that is 3. So what would be the timing for that one? For that case, if she eats 3 bananas per hour, then it will give 1, it will give 2, but it will give 3 hour. This is the point where we will not get the uh, our required solution. Okay, it will give 3, then it will again give 4 hours, because we are working with the seal value. So the total hours that she has taken in 3 bananas per hour, that will give us, this will give us 4 plus 3 7 plus 2 9 plus 1 10. Oh, oops, we just crossed the limit. We So in this particular rate she would be caught by the guard. This is not the helping case for her. So what we need to do is, we will need to give a minimal speed as well as the perfect speed, so that she can come finish it off in a given hour. So what would be the solution for this? Let us come to the coding part. It would be a bit shocking for you. So how this particular binary search is going on to, we are going to apply on it. Actually we are not applying anything binary search over here. We are actually trying to work with the iterative model. Maybe you can say that we are actually going to each element again and again. We are actually not applying the binary search in it. But why this problem requires the binary search? Just to reduce the time complexity, because we can also uh, work with the same approach that I have already and that I am telling you to work with. So what would be the approach to solve this particular problem? So what we are going to do is, so this is the problem statement over here. At each time, what am I doing is, at each iteration, I am going to the element first and dividing it by the an integer that which divides it, on which we can work with the binary search. Okay, let me tell you again it. Let's suppose we are actually working with the hours. Okay, let me. Could you please look into it over here? Okay, what would be the maximum rate of completing, or what would be the maximum rate of this particular solution to complete the all bananas? It could be any number of here. Maybe it would be the 11 or 100 or something, anything over here. But we are working with the minimum integer, so we can we say that the 11 bananas per hour would be a solution for it as a maximum. If you take it, that you can have the 11 bananas per hour, 11 and bananas per hour, 11 bananas per hour, 11 bananas. So all those things, all those stuff will give a 1 hour for each pile. So that Coco can easily finish it off in a 4 hour. But so the maximum value, what would be the maximum value for it? Maximum value would nothing but the maximum value of your array. Okay, array. And what would be the minimal? Minimal would be anything. Like we can also finish it off with from z, starting from the 0 or 1, whatever we want. So zero is nothing because zero is nothing a rate. So we can take 1 bananas per hour as a minimal, because we can also take the minimal value of it. But yeah, we can, but we need to give the minimum value of it. There is nothing constrained to the minimum over here, but the minimum would be 1. Okay, so this would be the range. Yep, and a range would be applied in between the min and max. And yeah, now we can use our binary search approach over here. How? Let's see. We are having a minimum value and we are having the maximum value. In between, we need to find out a value, a perfect value, a perfect minimal value, which is satisfying our problem statement. So again, we would be taking a mid element, which would be nothing but it's just addition of those elements, and then we need to divide it by 2. Okay, fine, we are having a mid element. So Ashish, what should I do over here? What we are actually doing? We are doing nothing. We are having another function. We would be having another function which will store the array and the mid as well. Okay, then what we need to do is, for each element of array, let me tell you, for each element of array, uh, we are actually doing nothing. We are actually dividing the value, that is each, by mid first. Okay, In this case, we are actually dividing the each element by the midest element, okay, and taking the seal value of it. That is the upper limit of it. We are having the maximum element, we are having the minimum element, this one, and we are applying the binary search over here, and then check whether this is actually satisfying the condition for our test case or not. So what we are going to do, we are dividing the each element by the mid, so and taking the seal value and store it into another variable that is required required time in in hour hour to finish what? Bananas. Okay, this is the variable which will store, but for each time this value should be added. Maybe we can write it as plus equals to. Yes, Yaram. So why I hope all of you are aware with this particular sign, plus equals to. This is nothing but a common statement, common line in coding, that a equals to a plus b. Again we can replace it by a plus equals to b. Okay, fine. So at the end we would be having the required time to finish the all bananas for the case, and then what we need to do is we just need to check whether this value is lesser than or equals to hours, the given hours in which the guard will return. Okay, if it is lesser than that, yeah, then we can easily return it, or we can store this value in any value in anywhere else. Okay, so this would be a solution for us, but this could be a solution, this is not a solution, this could be a solution. And why we are taking assistant, the help of that particular what the binary search is just to get the exactly helpful mid element which will satisfying the our case. So if we are returning it, then why we are actually worried about it? If any such point of time we are getting the answer, then why we are worried about it? No, here we are having the value ans, that is answer we could have, but what we need to do, what we are just trying to approaching towards the solution over here. So again we need to check, and we again need to compute the value of it. Okay, let me tell you why. These are the hours that we are getting with the help of made, and which is already lesser than is equals to h. Then what we can do, we can again remodify our max. How? By converting it to the mid minus 1 again. Okay, mid minimum is again over there, but max is mid minus 1. So what it is saying, we are having this case that is lesser than equals to, we can put max is equal to mid minus 1 over here, and again we are calculating the same thing, our ans variable. But what if we are getting the greater value of it, that is greater than the h? So okay, in that case what we can do is the right portion will contain the exact answer. I hope you are getting my point. Let's have a quick uh, overview on another thing, that let's suppose over here, let's again go with it. Let's say in any point of time we are having a 3, bananas per hour, then in the particular the sum of the hours to take to finish these things are 1 2 and then 3 3 and then 4, then 4 plus 3 7 8 9 10 hours, which exceeded the upper limit of hour. Okay, then what we can do is we just need to uh, increase the minimum element, the mid, that is 3 over here. So how can we replace it? We need not to do anything. We just need to write a else case over here, in which we are converting our min is equals to mid plus 1. As simple as that. And at the end of the complete solution of it, we can also look into it that our minimum variable is shifting towards the right, approaching to the solution one, but the maximum is always having a solution with it. So can we say that after calculating the whole this particular scenario, we can easily return our min variable over here? I hope you are getting my point. I'll be using some diagrammatic overview as for the next cases, for the next upcoming videos. So we can, let's approach to the problem and the coding solution of it. So this is the function that we are provided in lead code, in which we are having piles and the given hours. What I have done is I have taken the low value, the high value. Oh, what is this max in? Max in nothing but the maximum value. It will compute the maximum value of piles. Where is it written? Okay, over here. So I have done nothing specific over here. I have just iterated through the array and just computed the maximum value over here and returned it back over here. Okay, fine. We are having the lowest value, the highest value, and now the magic of binary will come. Now we are comparing until the low value is lesser than the high. Okay, first we need to compute the mid one. Okay, for each iteration we are computing the mid element, and oh yes, this is the actual solution in which we are going to finish all the bananas. Okay, so required hours, there's a function, another function required hours, in which we are doing nothing. We are just dividing the each element by the mid element. Okay, let's go to there. This is the hour, this is the array, and let's have a variable total hour over here, and this is nothing but the length of that particular array. So let's find, for each iteration we would be finding the total hours for each element, and we are doing nothing but this is the exactly same thing uh, which is written over here, which I was trying to tell you. And over here I am also telling you the divide by the hours that we are working with. Okay, so for each time we are calculating total hour and adding it into the total hour variable and storing it and returning it to the function from where it is asked, the double variable and double. Yep. Okay, fine. After that, after getting this particular value, we are having the integer value of it after converting into the seal value of it. Okay, now we are having the required hour to finish it in the mid by the taking of the mid, that is nothing but a rate of eating bananas. Bananas. Sure. Okay, now we are having another logic. If our solution is lesser than equals to s, then absolutely we need to come back, or we need to pull our I pointer to the mid minus 1. This is exactly same that I have told you over here. In case of answer, we would be having max equals to mid minus 1, and in the other cases, when we are having solution greater than h, then what we are going to do, we are just uh, pulling our low variable from the lowest one to the, just increasing our low value to the mid plus 1. And after computation of all these things, we are actually returning the lowest value, because the low variable is approaching towards the answer. Initially it is not pointing to the answer, but at the end it will definitely point to the answer. But higher variable will always pointing to the answers. So yeah, we can go with it. I have already submitted this problem, and yes, I hope all of you are getting my point successfully. What I have done in this particular solution, I am going to tell you again. This is the function that I have been provided. I have taken the low and maximum value of piles, and just applying the binary search in between them, just to get the smallest or the minimal integer that is satisfying this particular condition. Just divide by our condition over here. So thank you everyone. I hope you will enjoy your